Hello friends, welcome to PSCAD tutorials for beginners. In this series of tutorials, we will explore PSCAD software for the modeling of electrical and electronics systems. In this series of tutorials, we will also discuss the application of PSCAD for the modeling of electrical power system from basic to advanced level. The term PSCAD stands for Power Systems Computer Aided Design, and it is a time domain simulation software for analyzing transients in electrical networks. It is a collection of programs providing a graphical user interface to electromagnetic transient program EMTP. It provides various models and components of power system equipments to design and simulate a real power system. PSCAD is a professional tool which can simulate control system and complex networks. It provides a very flexible and effective platform for carrying simulation of various faults, power quality events, short circuit analysis, relay coordination, power flow analysis, microgrid studies, renewable or distribution generation study, mitigation of power quality, overvoltage or lightning studies, HVDC application, and many more. So these are the basic applications where power system computer aided design software can be used. But these applications are not limited to this. PSCAD comes with a library of models that have been programmed and tested, ranging from simple passive elements, control functions, and more complex models such as electrical machine, track devices, transmission lines, transformers, and cables. Other capabilities of PSCAD includes but not limited to create new custom components, run a simulation, enable circuits to be schematically constructed, analyze the result, manage data in a completely integrated graphical environment. EMTDC is the software which actually performs the electromagnetic transient analysis on the user-defined power system, while Power System Computer Aided Design is the software that uses the graphical interface. PSCAD assists engineers in planning, designing, commissioning, operation, preparation of specification research, and teaching. It is used in planning, designing, developing new concepts, testing ideas, understanding what happens when equipment fails. The following are some of the studies generally performed through PSCAD: insulation coordination of AC and DC equipments, designing power electronics systems and controls, subsynchronous oscillations, their damping and resonance, distribution system design with the custom power controllers, and distributed generation. There are also some applications, for example, the variable speed drives, their design and control, wind power and PV modeling studies, modeling and applications of FACT devices, HVDC control and project management, power quality analysis and improvement, distributed generation and power quality study. Investigation instabilities due to harmonic resonance or control interactions. PSCAD EMTDC thus allows more realistic representation of system through its physical components. We can also use MATLAB, but there are some advantages of PSCAD. Therefore, for the simulation of electrical power system, we prefer PSCAD over simulation or MATLAB. So the PSCAD is more advanced version for the modeling of electrical power system. So now let's discuss the PSCAD environment. So when we double click on the PSCAD icon, following screen will appear. So here you will see this screen. Now this is the background, this is the basic environment of the PSCAD. Now here this arrow shows the main menu bar, and this arrow shows the how to load the project. For example, when we have to model any system, we have to open a new window, we have to open a new project. So by click on this icon, we can open the load project. And here this is called the workspace, and this is called the master's library. Now here in this master library, you will find out all those components which are required to model any complex electrical system. So we can also further explore this master library by double clicking on this arrow. We'll discuss this in our next tutorial. We'll discuss master library in detail in our next tutorial. So here this is called the wire mode. For example, when we use different components, we have to connect these components. So here we use this wire mode to connect these components. And there is another facility provided in PSCAD, that is component wizard. So by using component wizard, we can model any component. For example, if any component is not available in PSCAD, so we can model a new component, and by using new component we can implement any control system. So we can say that we can model any control system by using this component wizard. As we can also interface the PSCAD and MATLAB. For example, if there is any component is not present in MATLAB or in PSCAD, so we can model our own component by using this component wizard. So we'll discuss this in detail in coming tutorials. Now here, this is how we can open the new project. So when we click here at this point, and then click on the new project, a new window will appear. So to create a new project, we have to open this new project. So when we click here, a new project will create. So to explore the master library, we have to double click on this arrow. Now when we double click on the new project, a new window will appear. So here this window is called the design editor, and we name this as PSCAD task 1. So this is the window where we model all complex and simple system. So the component required to model any system can be used from the master library. When we double click on the master library, a window will appear where all those components are available which are required to model any electrical system. So now this is the window where we have to model any complex system. Now if we want to further explore, we have to double click on the components. So when we double click on the components, so here you'll find out another window where you'll find out the basic components which are required to model any simple or complex control system. And once we have modeled the system, then to run the simulation, we have to click on this run. The project will show all the results. Now here, when we double click on the components, you'll find out these basic components which can be directly used from this window. So here these are called so this arrow shows the basic components which includes resistors, inductors, capacitors, ground. So these basic components are available. And here this is called the bus component. To model any electrical system, we require a bus. So here this is our bus. And here these are called the meters. So this is our meter section. In this meter section, you will find out ammeter, voltmeter, wattmeter, and multimeters. So all these components are available in this meter section. So here this is called the input devices. For example, a slider, switch, output channels. For example, this output channel is used to analyze the response of the system, output response of the system. So here this is called the data level. For example, if we want to connect two or more than two components without using any wire, so we use the data level. So here this is our data level, which is used to connect two or more than two components without using wire. To make this system simple, we use different data levels so that our system remains simple. And here this is our real constant. For example, if we want to give input to any component, a real constant is used. And here these are called the plotting components. So for different plots, XY plot, control panel, graph pen, so these components are used for the plotting of our results. And here this is our integral constant, which is used to give any constant input to any component. So this was all about the PSCAD environment. Now we are going to discuss these all things directly on PSCAD. Now here is the main window which appears when we open the Power System Computer Aided Design. So here this is the master library. So these are the different sections of the master library. We'll discuss this in the next tutorial. Now when we click on the component tab, you'll find out all those components, all those basic components which we discuss in the slides. So these are the basic components which we discuss in the slides. So to model any simple system or any complex system, we use these basic components, and we can also use the basic components from this master library. For example, if we click on this individual components on individual sections, for example, these are the basic components, and similarly if we require sources and other meters, we can also copy from the master library, or we can also use these basic components directly from the component tab. Now if we want to model any new control system, for example if we want to model a controller, then by using this component wizard we can also model a new controller. For example, here we model this new controller and we name this as power flow, and we title this as power flow, and then we define the number of inputs and number of outputs. For example, we define the number of left side ports and right side ports, and then if we want to add further, we'll define the name of the port, type of the port, input or the output, and the data type. Similarly, for the right side port, we'll define the input type or the output type and the data type. For example, it's logical or real data. Okay, so we'll discuss this when we discuss about the how to model the new component in PSCAD, and we use these components when there is no component available in the PSCAD or in the MATLAB. So here when we click on this tab on this new project, a new component window will appear. So here we have to name this. For example, we name this as new model, and when we OK this, so a new window will appear. So this is our design editor. Now to model any system, we use this design editor. We'll copy all those components from this component tab or from the master library, and we'll put all these components in this design editor, and then by using the wire mode or the data level, we connect these components, and then we'll get the final results. So this is the end of today's tutorial. In the next tutorial, we'll discuss about the master library in detail.